Very good morning, all. Welcome you all for the next lecture series. In this series, we are going to discuss about electrical motors. Under this, first motor is servo motor. So, servo motor is a rotary or linear activator that allows for precise control of angular or linear position, velocity, and acceleration in a mechanical system. Mainly, it consists of motor, position sensor, feedback system, gear train, and control circuits. So, gear mechanism connected with the motor provides the feedback to the position sensor, and servo motors being many manufacturers are there. So, under this Futaba, High Tech, Airtronics, and the JR radios. So, mainly they are considered are manufacturers' name. This is a servo motors constructions. So construction consists of stator winding, rotor winding, bearing, shaft, and encoders. What is meant by stator winding? This type of winding wound on the stationary part of the motor. It is also known as the field winding of the motor. And rotor winding is also called as the armature winding. And bearing, these are two type of that is front bearing and then back bearing, which are used for the movement of the shaft. And shaft is the armature winding is coupled and the iron rod is known as shaft of the motor. So encoder, it has the approximate sensor which determines the rotational speed of motor and the revolution per minute of the motor. So next is working of servo. So working of servo, which consists of the block diagram here I shown. So which consists of first one is pulse width modulation voltage converter is connected to the comparator. So output of the comparator connected to the error amplifier, and output of the error amplifier connected to the motor. So the gear train box connected to the position sensor connected to the input to the comparator. So along with this we have another block is the control signals. So let's see the working of this diagram. First one is the position sensor provides a feedback signal corresponding to the present position of the load, and this sensor is normally a potentiometer that produces the voltage corresponding to the absolute angle of the motor shaft through the gear mechanism. Then the feedback value applies on the input of error amplifier, and the error amplifier is a negative feedback amplifier, and it compares with the voltage related to the current position of the motor with the desired voltage related to the desired position of the motor, and it produces the error either a positive or negative voltage. This error voltage applied to the armature of the motor. If the motor is more than motor armature gets more output. The amplifier amplifies the error voltage and powers the armature. And this one is the servo mechanism. Servo mechanism already you are discussed in the last block diagram. So which consists of comparator, amplifier, servo motor, and main slides and sensor given back to the feedback signal to the comparator. So servo motor mechanism is servo motor works on the phenomenon of the automatic closed loop system. The controller is required for this closed loop system. This controller is composed of a comparator and the feedback path if it has one output and two inputs. In this, for producing an output signal, the comparator is used to compare the required reference signals, and this output signal is sensed by the sensor. The input signal for the motor is termed as a feedback signal. On the basis of the feedback signal, the motor starts working. So comparator signal is called as a logical signal of the motor. The motor would be on for the desired time when the logical difference is higher, and the motor would be off for the desired time when the logical difference is lower. Basically, the comparator is used to decide that motor would be on or off. Proper functioning of the motor can be done with the help of good controller. So controlling of servo motor. So controlling of servo motor consists of controlled by pulse width modulation. So what is maybe we know that what is pulse width modulation. The width of the pulse is varied in the range of 1 millisecond to 2 milliseconds, and transfer this to the servo motor with repeating 50 times in a second. The width of the pulse controls the angular position of the rotating shaft, and these three terms are used, which shows the controlling of the servo motor, that is maximum pulse, minimum pulse, and then repetition rate. So for example, the servo motor moves with the pulse of 1 millisecond to turn motor towards 0. So whereas a pulse of 2 milliseconds to turn the motor towards 180 degree. Between the angular positions, the pulse width interchange by itself. So therefore, the servo motor turns to the 90 degree with the pulse of with 1.5 milliseconds, and it shows in this diagram. So minimum pulse is in the 0 degree, neutral is in the 90 degree, pulse width modulation is 1 milliseconds, and for 2 milliseconds we can say it is the maximum pulse, and it is well aligned with the 180 degree. So type of servo motor. So DC servo motor, AC servo motor, and positive rotation. So DC servo motor, the separate DC source in the field of winding or armature winding. A DC servo motor consists of some components which are a small DC motor, feedback potentiometer, gearbox, motor drive circuit, and feedback control loop. These motors used in the computerized numerically controlled machines. And for AC servo motor include encoders that are used with controllers to provide feedback and closed loop control. This motor can feature high accuracy and has a high design of tolerances. They are used in the automation, robotics, CNC machines, etc. And positive rotations. In this motor, the motor output shaft of the motor rotates in 180 degrees. The motor mainly consists of physical stops which are in the gear mechanism to prevent the rotation sensors from rotating. These are commonly seen in radio controller, water, radio controller cars, panels, robot, toys, etc. So we can see the remaining part, advantages, disadvantages, applications, and the type of servo motors see in the next class. Thank you all.